Hello, welcome back to Cracking the Cryptic and another puzzle by Blobs today. I do like doing Blobs puzzles because Blobs is such an exciting setter in terms of giving you something to chew on but not making it so hard that it's really attritional. I just enjoy Blobs' puzzles, and the great news is there's going to be a new puzzle hunt by Blobs. Now, not February but March. March's Patreon Sudoku reward, I believe, is going to be by Blobs, and that is brilliant because we do like bringing you puzzles by this remarkable constructor. Now, don't forget that, of course, February's puzzle hunt, Duality 3 by the Skunk Works team, and thanks so much to Riff Clown for coordinating that. Fantastic bit of work. We're really looking forward to bringing that to you. And of course, on Patreon, we have gridogram and connections and some crazy cryptic crossword videos. So do check those out. They're good fun. Now, what else have we got? We've got all of our apps, which do feature Killer Sudoku and Domino Sudoku, of course. But Classic Sudoku is the latest sort of 60 puzzle app. And then there's all of the worms that exist already. And there's going to be one by Blobs. Yes. Great news. So it's not out yet, but it will be in due course, and you'll hear about it from us, obviously, because we do like to keep you informed of things like that, especially. So let's go through the rules of today's puzzle, and hopefully we can solve today's puzzle, and you'll see what I mean about the standard and style. We're already looking at a very beautiful pattern of black dots. But anyway, the rules are, normal Sudoku rules apply. So 1 to 9 will go in every row, every column, and every 3x3 box. Black dots separate digits where one is double the other. And in cages, there aren't any repeat digits, and they sum to the given value. So these 3 will add up to 8, for instance. That's all there is to it. Very simple rule set. Give it a try. I'm going to start now. Let's get cracking. Not only a simple rule set, we have a 17 cage where I can write in that there must be a 9 and an 8. Now, there is something else we know about 3-cell 8 cages and 3-cell 22 cages. And that is, in the case of the 8 cages, they must have a 1 in somewhere. I'm not going to pencil mark that because I don't love pencil marking across boxes, but I am going to pencil mark a 9 nonetheless in the 22 cage. Now, if you think about how to get to 22 in 3 different digits, you'll work out that it's either 985 or 976. Those are the only 2 alternatives. So there must be a 9. Now that digit can't be a 9, but equally in this 22 cage there must be a 9, and that's now in one of these 2 cells. Now, if we take this over to column 1, there must be a 9 in that group, and there must be a 9 in this cage, but now it can't be in column 1, because the 9 for column 1 has been taken. So now we can place the 9 here in this 22 cage, and that looks across and resolves the 9 in box 9. And then there's going to be another 9 in one of these cells, but I've seen something that is quite important, and it's to do with the layout. So if we were to, what I'm going to do to show you what I've seen is colour all of these cells and then tell you what the 6 digits that can go on a black dot in a Kropki puzzle are. They are the numbers 1, 2, 3, 4, 6, 8. Now, Mark, you're wondering, what are the 3 Sudoku digits that cannot go on those black dots? 5, 7, and 9. And if you think about 5, 7, and 9, those digits don't have any numbers that it can be used in Sudoku and are either double or half of them. So these cells in these columns are 5, 7, and 9. If there were 2 of them in 2 columns, we'd call it an X-wing. When it's 3 in 3 columns, we call it a swordfish. And the exciting thing about this swordfish is that I could now colour the remaining cell, because in each column we're going to use 5, 7 and 9 once each. We must be doing it in those 3 rows that are involved as well, because this is an exact grid matrix. So the remaining cells in those rows will also be from 1, 2, 3, 4, 6 and 8. Let's make them yellow. And that means that these two cells can't be a 9, and we've found where 9 is in row 7. Now I can remove 9 as a candidate from those cells. And Blobs is almost giving us a lesson in Sudoku theory here. Now these two are also coloured yellow. They can't have a 9 because they see a 5, 7, 9 triple in the row. So in these 22 cages, the 9s must be forming an X-wing this time, which is either a pair there, and imagine the line connecting those, or a pair there. And if you imagine the line connecting those as well, you've drawn an X. That's why it's an X-wing. So again, all of these cells can't contain a 9 because the 9 in row 3 and 5 must be in one of the perimeter columns. And that means that the 9 in box 2 is in one of those cells. Now we already know that the 9, we know the 9 is not here on the black dot. I could have done that right at the beginning. I didn't notice it. I could really have done it once I put a 9 there. But now that tells me where the 9 is in box 2. And apart from this X-wing, we've got all the 9s in the puzzle. They're all done. And we got that 8. That means this is a 4. It is worth noting that in each of these columns, you can't have a 2, 4 black dot. And that's because you have to put all the digits on black dots. Clearly 3 and 6 will go together. That's one little family of black dot digits. The other family is 1, 2, 4, 8. And normally you could have either 1, 2, or 2, 4, or 4, 8. But since 8 must appear on a black dot, for instance, in this column, it must go with 4. And 1 must go with 2. So there's no possibility of 2 going with 4. Anyway, we found one of these pairs now. And that digit means that neither of these can be a 4. So it's quite difficult now for this cage to be... I'll tell you what's interesting is neither of those digits can be a 5 either because they're yellow, basically. We've said that yellow digits are from 1, 2, 3, 4, 6, 8. They don't include 5. Right, an 8 cage needs either a 4 or a 5 in it. This 4 prevents either of those yellow cells being a 4. And these 5, 7, 9 triples prevent either of them being a 5. So the 4 or the 5 that must be in the cage must go in that cell. And the other two are either a 1, 3 or a 1, 2 pair. One of them has to be a 1. Now, down here we've got a 5 cage that is really the only cage. No, I haven't considered that 8 cage, but apart from that, it's the only cage I hadn't considered. This digit now, not a 4, is 1, 2 or 3, and that makes this digit 2, 3 or 4. Now, there might be a reason I could rule out 4 from that, but I can't think of what it is. Okay, there is. It's a little bit complicated though, but let me take you through it. If this was a 4, that digit would be a 5. So this would be a 1, 2 pair. But if that was a 4, this would be a 1. And this would also be a 1 or a 2. But one of these black dots has to have 3, 6 on. So it's just not possible for this to be 4. This pair is a 2, 3 pair. And that digit is actually now therefore either 1 or 6, because there are no 2, 4 pairs on our black dots in this puzzle. I think similarly here, no, maybe not. This is 1, 2 or 6. Don't know about this cage yet. Okay, I'm not going to remove the yellow yet, but I'm going to talk about flavors. So I discussed earlier that there were 2 ways of making up an 8 cage, 1, 2, 5 or 1, 3, 4. There are also 2 ways of making up a 5 cage, 2, 3 or 1, 4. Now you could call those flavors, which doesn't really matter, but it does a bit in respect to the 22 cages. So there are 2 ways of making up a 22 cage. And one is using 985 and the other is using 976. So let's deem that this cage is a green flavour, and this cage is therefore a blue flavour. Oh no, let's contrast green with red. So these digits, yeah, this digit isn't allowed to be 5 or 7, so that is 6 or 8. It's not allowed to be 9 either. And the other one of 6 or 8 in the green flavour is here. But one of these is a 5 or a 7 as well, and the other one of those is there, so I could colour that cell red. Now, only one of 5 or 7 is red, the other is green. That one is green. These two are red, which I could have worked out from that cell or from this one. And now these two are green, because otherwise we'd have 3 reds in the column. This cage is green, because otherwise we'd have 3 reds in the column. Now again, this cell has to be 6 or 8. It's the green version of 6 or 8, whereas that one's the red. And now this digit can't be 6 or 8, or 5, 7 or 9, so that's 1, 2 or 3. This one can't be a 1 because of this 8 cage, so I'm going to put 2, 3, 4 in there as possible. That doesn't quite help resolve it, but we're getting somewhere. Not quite sure where we're getting. We had a green there and double green here. I'm just wondering where the second green in this box is. It can't be in those cells. It could be in these because it is 6 or 8. Yes, okay. I was trying to rule it out of there, but I don't think I can do that. And maybe this policy of colouring reds and greens has not proved likely to be successful. Yeah, that can't be green 5 or 7. So green 5 or 7 in row 4 is in one of those two cells. Red 5 or 7 is in one of those two. And this one must be green or red because it's not 9. I don't know. I think I'm managing to confuse myself rather mightily at the moment. Can that be an 8-4 cage? I think it could. Those cells would be 8 and 4 there. Sorry, not cage. An 8-4 black dot was what I was wondering about. Okay, I need to think of some other way of progressing. It's a very interesting puzzle with a lot of theory in it, certainly the way I'm solving it. Maybe you don't have to solve it this way. The colouring didn't quite do anything. Well, this digit cannot be red, but it could be 9, and thus it could be sort of green. This digit can't be red because it sees the 6-8 version of red and the 5-7 version of red. So it's either green 5-7 or it's a 9. I just feel like I don't quite know where the breakthrough's meant to come from in this puzzle. 9 in this box is definitely in one of those two cells. Oh, I see. We've got left with this 9 X-wing and this 9 X-wing. And they basically represent 2 positions for 9 in each box involved. That's quite intriguing as well. There's only one possible overlap digit between an 8 and a 22 cage, and that is the number 5. Now, if there was a 5 in this cage, it wouldn't be here, which sees a 5-7 pair. It would be in one of these cells. So these would be 5, 1, 2, and there'd be a 5 here. Now, does that mean this couldn't be the 9, 8, 5 cage. I don't think it does, because you could do that by having a 5 here. And then that would be a 5. I don't know, I feel like there's something going on with this. This cage is kind of the last one left over, although I haven't really thought about this one either. Oh, maybe that digit. Can that be red or green? If it can't, it's 4. I don't know. I'm sorry, I don't know quite what to look at here. Maybe that 2-3 pair. I haven't really thought about that. These digits can't be 2 or 3. They must be from 1, 4, 6, or 8. No, I don't know. I don't think that's all that helpful either. Goodness, you're going to have to bear with me while I figure something out. Okay, one of these digits is a 1 in the 8 cage, and that means these two must see that, and they can't include a 1. So the 1 in the box is either in a 1, 2 black dot there, in which case this is 6, 3, and that's 2. Or 1 is in one of those cells, in which case in column 5 it would have to be there. If this is a 1, that's a 2, and this digit is 3. And that's very formative. That gives us a 4 and a 1 definitely here. If this digit is 3, that's a 4 and that's a 1. So what would happen then? We'd have a 6 here. If this digit is a 3, I don't quite know. Sorry, I'm stumbling around a bit here. Something must be eliminated between these cages and dots, but I don't know what it is. Okay, let's go back to this 8 cage where there's a 1 in the 8 cage. That is either going to put a 1 in one of these cells and then a 1 in one of these black dots, or it starts with a 1 there. That would need a 1 to be here in this 8 cage. I don't know, again, I don't know quite what that does for my puzzle. I know what it does for my confidence, which is falling through the floor at the moment. I don't know how to solve this. Right, maybe I should have done more with 9s somehow. We know 9's in one of those cells. I suppose one of these is green, so the 9 on this, in this column is the red one. I don't even know if that's right. Why would that have to be right? Is there a distinction between a green 9 and a red 9? No, there probably isn't. I think I'm talking utter nonsense now. Oh dear. Right. I was quite pleased when I deduced that this was 4 or 5, but it's done absolutely nothing for the puzzle. If that's a 5, this is the 5 in the central column. Then there has to be a 5 in one of those two. Where else has a 5 become mandatory, I wonder? No, I really don't know. Goodness. Okay, Blobs has got me fooled with this matrix. Okay, let's go back to these then. These are either 5, 8 or 6, 7. if that wasn't a 2, sorry, if that was a 2, neither of these could be 3. Does one of these dominoes have to be a 3-6 domino? It's an interesting question, but I think the answer is no, unfortunately. I don't think there's a reason why that's necessary. Oh, here's a thing. These are 5, 6, 7, 8, 9. So everything else in this column is 1, 2, 3, or 4. Well, I could colour them all yellow because I was trying to sort of make any cell that had to be 1, 2, 3, 4, 6, or 8 yellow. Now, how many of these are from 1, 2, 3, 4? My answer is at least 1. Whether this is a 1, 2, which would have 2, a 3, 6, or a 4, 8, it has at least one really low digit. Now, I also think this pair has to have one really low digit. And I think this is key to the whole puzzle now. There's got to be one low digit there. I'm talking about 1 to 4 as the low digits, and 1 here. And that means one of these two is not from 1, 2, 3, 4, and is therefore 5. So this is a 5, 1, 2 cage. And there is a 5 there. That's now not a 5. I was going to say, and is green. That might not be a fair deduction, but there is a low digit from 1 or 2 here. So this cannot be a 1, 2 black dot, which actually it couldn't have been anyway. It's either 3, 6 or 4, 8. If it's 4, 8, we know which way round it goes. If it's 3, 6, we don't. But we now know this is 1, 2, 5. That digit can't be 2 anymore because it sees all of that 1, 2, 5 cage. This is 3 or 4, and there is a 3 or 4 in this pair. So this digit is from 1 or 2. Now, there's a 1, 2 black dot in this column, and it's not here because that would break this cell. So it's up here. That's a 1, 2 pair. These cells are a 3, 4 pair. That digit is now 1 or 2. We've got lots of 1, 2s circling around here. I could say that that's not a 1 or a 2 by uniqueness, but we don't like to use uniqueness to solve puzzles. Maybe just to point out things. Now, that digit is a yellow digit, but not 1, 2, 3, or 4. So that's 6 or 8. Now, come on, Mark. This must be a black dot pair, effectively, because that is a black dot pair. If that's 3, 6, this is 4, 8. If that's 4, 8, this is 3, 6. So we can conceive an imaginary black dot here. And I wonder if that has to be another one, leaving this to be a 1, 2 pair. I don't know that yet. Do I know anything about this 8 cage, having discovered that this is a 1, 2, 5? Oh, I've got this 1, 2 pair here. 1, 2, 5, 7, 9. So everything else in this row is 3, 4, 6, and 8. So if that was 6, 3, this would be a 4, 8 pair. And that would make this a 1, 2 pair. With that being a 1, 2 pair, that would leave 1 and 2 up here. We would know which way round they would go because the 8 cage has to have a 1 in it. So if this is a 1, 2 pair, that digit is 2, and this one is 1. One of those is 1, and then one of these is 1. So we'd have a 1, 2 pair here. This is all founded on this being a 1, 2 pair. In fact, in this box, one of 1 or 2 is going to have to go on that black dot. None of them are going in red. None of them are pencil mark possible there or in those cells. One of them could go here in theory, but in practice, one of them's going to go here. And once one of them goes on one of these black dots in columns 3, 5, or 7, it must go with the other one. So this is a 1, 2 pair here, and we know that 2, 3 are looking at that cell. So we actually know which way round they go. And now we found a 1, 2 pair. These ones are very similar in terms of pencil marking to these digits. So one of them is a 3, 6 pair and the other is an 8, 4 pair. This is also either 3, 6 or 4, 8. is that a 1-2 pair? In which case that is... I have a feeling it probably is. And my feeling is based on the fact that if this wasn't a 1-2 pair, so if this was a 6-3 pair, would these two have to be 1 and 2? I'm not sure about that, so I'm not going to place any reliance on it. Okay, let's come back down here where we got the 1 and the 2. 2, 2, 2. 1, 1. One of these three is a 1. This digit is a 6 or an 8. No, it's, oh, I don't know. It might be a 3 or a 4, or it might be a 6 or an 8. I don't think I can tell yet. There's a 3 in one of those cells. So one of these two cells must be a 3, because we can't put a 3 in the 22 cage. Oh, and there's a 3 in one of those, so these don't include a 3. Now we know one of these two is a 3. And these digits contain a green one, which is either it's 5, 7 or it's 6, 8, and a 4. One of these two digits is definitely a 4, because we still need a 4 for this row. If it was here, that would be 8, that would be 3. What would that do? That would make this a 4-8 pair as well, I can see. I don't know quite how we break through from there. This digit now is 4, 6 or 8. It can't be 1, 2 or 3. 4 always goes with 8 on the black dot in this puzzle. 6 with 3 and 8 with 4. Ah, we're not there. We're not there yet. One more breakthrough needed. Okay, let's go back to thinking about if this wasn't a 1, if this wasn't a 1-2 pair, if that was a 6-3 pair, what does that do? That makes this a 1-2 pair. It doesn't really change much down here. Oh, it's already clear. No, I was going to say that this is a red digit. That's not clear. This could be a 3, in which case that's a red digit. This can't be a red digit. Oh no, that could be. Oh, bother. If it was an 8, this could be a red digit. Red is in one of those two cells, because two reds are seeing those two. So one of these two is red. And then that must also appear in one of these cells. And I don't know where else. Oh, this must be green. That's quite interesting. Green, the green cells I'm trying to colour are either a 5-8 pair or a 7-6 pair. But all the green cells see these cells. That's red, so it's not green. This has to be green. Therefore, it's not 3. And we've found where 3 is in the box. It's also not 4, actually. 3 must be here. Now 4 is definitely in one of these two cells, which means that digit is 4 in this box. That's why I wanted to know. This can't be 4, that can't be 8. This is the red pair, that's the green pair. One of these is green, the other one is 4. Now there has to be a 4 in one of those two cells. Well, it can't go in green, so it does go here. So this is a 4-8 pair. That digit is a 3. I don't really understand why it's taken me so long to work this out. But there we are. We get there when we can. This is green in the bottom row. This box, 3, 8, 9, 4, 1, 2. Right, 6 appears in these two cells. So they are a 6-7 pair, and we now know the identity of green. Green is 6 and 7. So that digit is 6. The one on the other side of the grid is 8. Red digits are 8 and 5. And therefore this red is a 5. These are a 9-5 pair. Only one is actually red. Right, and these are a 9-7 pair. Now I've done all that, I'm going to remove all the green and red from the puzzle because it's kind of done its job. Probably the yellow has as well, but let's just look in this bottom row. This digit is 6 or 7. In this column, yeah, as long as we know there's a 5-9 pair here, we're finished. 5, 8, 4, that can't be 5. And these two can't be 7. Oh, I thought one more breakthrough was going to be enough. I may even have said that. There's a 5 in one of those cells, so that digit is 9. I think I may have been right, incredibly, for the first time in a while. This is going to sort out the whole swordfish that we started with. They're all done. Okay, I probably don't need the yellow anymore now, but let's just leave it for a moment. Might be colouring 1s and 2s in a moment though. So, 6 there means this is an 8-4 black dot, and that is a 3-6 one up at the top. Now, still haven't resolved this. 2, 9, 4, 3, 8. We need a 5 in the row. I don't know how to deal with that yet. That 9, 7, 6 pair, 3, 4, everything else. Okay, these are from 1 to 8 because they can't be 5. This one can't be 8. So that's from 1 to 5, and that's forming a triple in the row. Everything else in the row is from 3, 6, 7, including this digit being 3 or 7. Now, what about this 8 cage? If it's... Oh, hang on, that 9 sees this cell. Sorry, all the 9s should be done, of course. So that's now a 7. That makes this digit a 3, and that's really important. This cage now can't be 1, 3, 4, and must be 1, 2, 5. The middle digit can't be 5. These can't be 3, so that one's become a 6. That's a 7, that's a 3. Now, where are we now? 1, 2, 5, 3, 6, 9. That must be 8 at the bottom with a 4, 7 pair at the top. That's 7 in row 3. This is 6 or 8 in the column. Sorry, I'm going to have to cough in a moment. It's so annoying at this stage. We're nearly finished. Desperately trying to keep it at bay. Right, there's an 8 in one of those cells. This can't be 5. Only one place for 5 in the box. There it is. That gives me the 5 in box 4. Now, these are from 1, 2, 6. Should probably know the order. These don't have a 6 in, so they're definitely a 4, 8 pair. 4, 8, 9, 2, 3. 7 can't be here. This is a 6. That's a 1. That's 7. That's 5. On the black dot, we get 2 and 3. On this black dot, 3 and 6. 3 and 6 on the other one. 3 and 6 and 3 in the corner. That's 3 in the corner. That's 3 in the spotlight, proving its position. And we are making very good progress now. That's a 1 or a 2 in this row. That has become a 4, which was doable by considering the killer Sudoku cage. This must be 3, not 2. These don't have a 1 in, so the row needs a 1. Then we can do 2, 1, 2. We can do 2 and 1 up here. This is an 8. This is 5. That 8 gets me the 8, 4 pair. The 1-2 pair is done by a 1 that is already in the yellow cells. Let's get rid of the yellow now because it's certainly not necessary anymore. We can just fill in 6 and 2, 6 and 7, and there we go. We have completed the matrix. It is a beautiful puzzle by Blobs. It took me a little while to really figure out how it unwound, but it unwound beautifully, and that's exactly what I expected at the beginning. Fantastic stuff. Thank you so much for joining us here at Cracking the Cryptic. Absolute pleasure to have your company. Love to see you again tomorrow if you'll come back and watch me try another Sudoku puzzle. And Simon as well, of course. Bye for now.